First, let's review some basic attributes of an array. Today let's take a look at arrays in C++. And arrays are collections of objects. And there are a few restrictions that apply to arrays. Arrays must be objects, or they must store objects of the same data type. So in other words, we can't create an array that stores both integers and, say, doubles or strings, or rainbow unicorns, or flying purple people eaters. An array, once it's built, cannot be resized. So it can't be augmented, can't be diminished. It can't grow and shrink according to the needs of the program. Once you build it, that's it. It's of a fixed size. Objects stored inside of an array are known or referred to as elements in the array. And the elements, again, they could be, if it's an array of integers, each element would store an integer. If it's an array of cats or dogs or flying purple people eaters, then each element would store a flying purple people eater or a dog or a cat or an integer. An object stored in an array is indexed by a subscript value, and this goes in square brackets, okay? And these subscript values, they start at 0, not at 1. We humans, when we start numbering and counting things, we normally start at 1, not at 0. But with arrays, we have to understand the computer always starts at 0. And this creates sort of an off by 1, or what some people call a fence post error. It manifests itself as a logic problem, not a syntax problem. So you can compile code where you're off by 1, in an array structure, and when you're using it inside of a loop. And it's not going to be a syntax error, but when you run the program, it doesn't do what you want. Or even worse, it may crash the program. You might get like a null pointer exception or something. If it goes past the last element in an array, or it tries to access something before the first element in the array. So it's just something to kind of keep in the back of our minds as we code projects that use arrays. We want to start at 0, not at 1. We should be careful, always looking for that off by 1 or that fence post situation in a project. And arrays are most powerful when you combine them with repetition structures, such as for loops, while true loops, do while loops, okay? Let's briefly review the objects and globals we will be using to demonstrate different types of arrays. To start out with, we have IO stream, since it's a console application, and we're implementing the string header file. I'm using the standard namespace, so that way we don't have to explicitly scope into anything. And to give us a user-defined object, we've created a rainbow unicorn class with a standard default constructor and destructor, and it's just going to display in the console what it's building, a rainbow unicorn or destroying a rainbow unicorn. We have a display stats function, which is going to take care of displaying two private data members, the string name and the integer age. And we have some public accessor methods or accessor functions whose sole purpose is to both get and set both name and age. In addition to our user-defined class here, we have a global, and its array size. And unlike Java, where you have the length attribute from the array class, there's no comparable method or data member in C++. So what we can do instead is we're going to create a constant. And remember, a constant in C++ is like final in Java. It means we can't change it. And we'll simply use this constant whenever we build an array and access an array. And we want to make it constant or final because if an array can't be resized, it can't grow or shrink, then we need to make sure that array size, the integer, neither grows nor shrinks. We want it to stay the same. We have our function prototypes here under prototypes. In main, we have all of these functions commented out, and we'll uncomment them one by one as we test different aspects and explore different features of arrays in C++. And then our function definitions, of course, are down here beneath main, and we'll just simply run them one by one. Declaring one-dimensional arrays. So let's take a look at our very first function here, and we'll uncomment it, and we're going to run it, and this just builds a one-dimensional array, and this is the simplest type of array, so it's a good one to start with. And here we're not even initializing these arrays with values, but I'm just showing you how to instantiate or build an array of a particular data type. So on the first line here, the statement, we're building an array of integers. Here's data type integer, And we're using our constant, our unchanging integer, global array size, which is 5. So this array here could hold 5 integers. The next array is an array of doubles, and it could hold 5 doubles. And then the third array is an array of strings, and it could hold 5 strings. And if I run this, again, it's not going to do anything. I'm not displaying anything, and I'm not really storing any values. I'm just building, but just to show you. And you can see it doesn't really do anything. While we're at it, why don't we modify the background color here? So hopefully it's easier for you to see what's happening. Okay. So that was the first example. We'll comment that back. Now let's look at the next example. Declaring and initializing a one-dimensional array. So now we're going to look at not only declaring a one-dimensional array, but initializing a one-dimensional array with some data. And so in the next example here, we have an array of integers that are pre-initialized, okay? So yes, it's got 5 elements, so we've declared that inside these square brackets here, the size of the array will be 5. But we're going to pre-assign or initialize it with values. In this case, the integers 1, 2, 3, 4, and 5. And those go inside curly braces, and each element will be separated with a comma. Next, we're going to create an array of doubles. Again, it's going to contain 5 elements, but instead of integers, this array will store doubles. And we'll pre-initialize it with 1.0, 2.0, 3.0, 4.0, and 5.0. Again, the elements are separated by commas, they go inside curly braces, and as always, we terminate a statement with a semicolon. Third, we're going to create an array of strings and pre-initialize it. It's going to be able to hold 5 strings, it's got 5 elements, and the elements would be 1, 2, 3, 4, and 5, the strings, the words, and again, the elements are separated by commas. So you can see how we can both declare and initialize a one-dimensional array in a single step. And then, of course, where arrays really shine is when we combine them with repetition structures like for, while true, and do while loops. So inside of our for loop here, we're just going to simply display the element of each one. And we'll loop array size is 5, so start at 0, 0, 1, 2, 3, 4, 5 times. And we'll simply display each element 0 through 4 for the array of integers, doubles, and strings. Okay, so let's run it and see what happens. We'll rebuild our solution there. And we will run it. Okay, and so you can see integers, doubles, and strings. 1, 1, 2, that's element 0. And 2, 2, 2, 3, 3, 3, 4, 4, 4, and 5, 5, 5. Declaring and initializing one-dimensional arrays of class objects on the stack. Now let's go to our next example. That was a one-dimensional array and declaration of objects, and in this case, integers, doubles, data primitives, and the string a built-in class. What about a programmer-defined object? In other words, a class that you write yourself. Well, let's look at that. Let's look at a one-dimensional array declared on the stack, and then we'll also look at one on the heap. But for now, the stack. So we're going to call this function, and what are we going to do? We're just going to say building an array of rainbow unicorns on the stack, and we're going to build an array of rainbow unicorns, and we're going to name our array bronies. And it's going to be able to hold 5 rainbow unicorns, right? Remember, that's our constant, unchanging global integer, has a value of 5. And we're going to cycle through that. 0, 1, 2, 3, 4 is what we'll do in our for loop. And we'll access the subscript value. And when we do this, we're going to call setAge. And by building this on the stack, we don't have to call new on it. We don't have to worry about a null pointer exception or anything like that. They already exist, and we can simply call setAge. So we're going to do that, and then based on the subscript value of x, 0, 1, 2, 3, 4, we're going to name them Ginger, Lemon Sparkles, Star Streak, Twilight, and Angel Feathers, respectively. And then finally, when we get down here, we're going to create another for loop, and just to display them, introducing rainbow unicorn number, and we're going to call display stats, And remember up here that in our Rainbow Unicorn class, display stats will take care of showing the name and the age of our Rainbow Unicorn. Okay, so let's take a look and see how this works with it, commented out. We'll rebuild the project. And we'll run it. And now we can tell here's, we're calling our constructor. So when we build the array, it's instantiating 1, 2, 3, 4, 5 Rainbow Unicorn objects. And introducing Rainbow Unicorn 1, Ginger, age 1, 2, Lemon Sparkles, age 2, 3, Starstreak, age 3, 4, Twilight, age 4, and 5, Angel Feathers, age 5. And then it's calling the destructor 5 times. When that function ends, then the entire array of objects falls out of scope, and so everything's destroyed and cleaned up. A pointer to an array of objects on the heap. Now let's take a look at our next function up here. Alright, so that was a one-dimensional array declaration of objects on the stack. And this next one, we're going to do a one-dimensional pointer. Oops, take out the extra parentheses here. One-dimensional pointer to an array on the heap of objects, which is substantially different from a one-dimensional array of objects on the heap. And I'll demonstrate what the difference is or what we're talking about. So let's take a look at this one. Alright, so here we have a one-dimensional pointer to an array on the heap of objects. In other words, the array itself is being built on the heap, okay? And bronies is simply a pointer to an object of type Rainbow Unicorn, and it's building the whole array of Rainbow Unicorns on the heap, instantiating it with the new keyword. And so the way we'd access it is with the dot operator, just like we would in Java, if we were dealing with arrays in Java. Okay, and we're going to simply set the age, and again, the names are all the same, and the same thing with the loop down here with accessing it. It's not much different than the code was on the stack. Here's the stack code up here. Not really much has changed other than, then we're using a pointer to access the array here in this example. And here's the thing, when we pass arrays to functions or when we access arrays, it bears mentioning that the name of the array itself is a pointer to the entire array, or all the elements, the objects stored in the array. So we can use the array's name as a pointer, bronies as a pointer. So if we run this, let's rebuild the project. And we'll run it. And as you can see, our pointer, we build our array of 5 Rainbow Unicorn objects on the heap, and the results are the same, except that this time we're pointing to an entire array of Rainbow Unicorns on the heap. Declaring and initializing, also known as populating one-dimensional arrays of class objects on the heap. Next, let's take a look at a one-dimensional array of objects built on the heap, stored inside of an array. And it seems like a very subtle change there, not like a big difference or a great difference, but it actually, in the way memory is managed and accessed, it's profound. Okay, so we're going to access one-dimensional array of objects on heap. Let's go take a look at that function. One-dimensional array of objects on the heap. And now look at our code. So now what we're going to do is first we're just going to set up bronies in this example is going to be a pointer to a Rainbow Unicorn. And we're setting up 5 elements here. So we have 5 pointers set up. When we do it this way, we've got to populate the array with objects. A quick and easy way to populate an array is with a for loop. And just loop for the number of elements that's in the array. In this case, we can use our constant global integer array size, which is 5. So 0, 1, 2, 3, 4 inside this for loop. And then we just need to use the keyword new and instantiate a Rainbow Unicorn for every single element in the array. Have to be careful when we're doing this because we don't want to end up with a null pointer exception or creating a null object. In other words, say that I forgot to build a unicorn at the last element, element 4, if I were to access that, my program would crash. I'd get a null pointer exception, or I'd have to try and catch that and handle the exception somehow. Okay, so we're just going to populate the array, and then in this next for loop, we're going to do what we were doing before, but the major difference is instead of the dot operator like we used here, and here when we built our objects on the stack, because we're using a pointer to access all of our objects, and we built them on the heap, we have to use the arrow to specify end direction. And so we're going to call set name and set age respectively, but this time using the arrow instead of the dot. But other than that, the results will still pretty much be the same when we call display stats. It's just how we call it with the arrow instead of the dot operator. And last but not least, we need to clean up after ourselves when we're done, so we're going to call delete in a for loop and delete all these objects. And let's go ahead and build the project to reflect our changes, and we'll run the project. And again, it essentially does the same as the previous one, except that now our pointer is pointing to and being used to build and then access all of these rainbow unicorn objects on the heap. Here's our 5 rainbow unicorns calling the constructor being built. Here are the names and ages. Nothing's changed there. And here's where we're calling delete inside the for loop at the bottom to clean up after everything. Declaring a two-dimensional array. And let's take a look at our next function up here. Everything we've done up until now has been, involving one-dimensional arrays, which are pretty much the simplest type of arrays that you can build. Now we're going to take a look at creating two-dimensional arrays. So we're going to look at two-dimensional array declaration. Let's hop down here to the function and see what the code looks like. And if we're declaring a two-dimensional array, it just has an additional set of square brackets and an additional subscript or index value. So in other words, let's say we're going to create a chessboard with 64 squares, 8 by 8 or 8 times 8. In this case, we'd have 8 rows and 8 columns per row. And if you want to think of it in terms of rows and columns, a lot of times a two-dimensional or a three-dimensional array will be used to create a matrix for a database or a data structure. And so the first subscript will be referred to as rows, and for each of those, the second subscript will be referred to as columns. So in other words, for every single row, for row 0, we'd start at 0, there's 8 columns, and then 1 all the way to 7, the last, there's 8 columns for each of those rows. And that's just for integers. Here's a two-dimensional array of strings, okay? And again, 3 rows and 3 columns per row, okay? So that's how you would declare it. And as we saw before, nothing really happens, if you just declare those objects. We're not actually displaying or setting the values there. So let's go ahead and run the program. We'll build it. And nothing really happens there. Declaring and initializing a two-dimensional array. Moving on down the list, let's examine the next function. So we're going to comment that back, and now we're going to comment the next one. And in this example, we have a two-dimensional array declaration and initialization. Okay? So let's look at both declaring and then initializing a two-dimensional array. So in this case, we'll use the chessboard example that we used previously. If I wanted to do that, notice that I'll try to highlight that. If you see a little shaded portion, Visual Studio, right? This represents both the rows and the columns, okay? So there's 8 rows. If you count them, and they'd be indexed to 0 through 7, but 1, 2, 3, 4, 5, 6, 7, 8. But remember that off by 1 issue, we start at 0, not at 1, so it would be 0, 1, 2, 3, 4, 5, 6, and 7, okay? And then the columns for each row would be 1, 2, 3, 4, 5, 6, 7, 8. But again, remember, it's we start at 0 and then at 1, so it would be indexed as 0, 1, 2, 3, 4, 5, 6, and 7. That's how we would access those values. So in other words, if I wanted to get at this number 4 here in the first row, this subscript here is 0, 0 through 7. This row would be 0, this row would be 1, this row would be 2, 3, and so forth. Well, if I wanted to get at that 4, then this is going to be 0. And then what is the 4? We'll count them. 0, 1, 2, 3 in terms of the columns. So chessboard 0, 3 would access that 4. Let's say I wanted to access the 7 right here. Okay, we'll count them. 0, 1, 2, 3, 4 rows. So the first subscript value will be 4. And then count the columns. 0, 1, 2, 3, 4, 5, 6. And that would be the column value. Alright, so 6 is the column value, and 0, 1, 2, 3, 4 as the row value. So chessboard 4, 6 would access that number 7 right there. Does that make sense? Alright, let's take another example. That was an array of integers, or a two-dimensional array of integers. What about a two-dimensional array of characters? Here we have a tic-tac-toe board. And on our tic-tac-toe board, we're going to have X's and O's. And here vertically we have, a situation where we're winning, I guess. More than once it appears, but just as an example, let's say I wanted to access, X in the center square. Well, what's the index or the subscript value of that? Count the rows, which is this first value, and then count the columns, which is the second value. So if I go 0, 1, then that's how I access the row. So that would be subscript value 1. And then I go 0, 1. Well, 0, 1, 2, those are the columns, but this is 0, 1. So tic-tac-toe, 1, 1 would access the center square. That's the X in the middle there. Finally, we have an array of strings. And again, in this case, we have 3 and 3. So 3 rows, 0, 1, 2, indexed accordingly. And 3 columns, 0, 1, and 2, indexed accordingly. Let's say I wanted to get at this value, this string stored here. If I wanted to get at this string stored here, how would I access it? Well, that's row 0, 1, 2. So this first subscript value here, the first dimension of our array, the row, would be 0, 1, 2. And then the column is 0, 1, 2. So it's the last column. So array of strings 2, 2 would access this string literal, stored right here in the array. So if we were going to, display the contents of a chessboard, contents of a two-dimensional array chessboard, then typically a way you can access, items in a two-dimensional array is with a nested for loop. And you can use the outer for loop to cycle through the rows, and you can use the inner for loop to cycle through the columns. And the way it would work is for every single iteration of the outer for loop accessing the rows, you would go through the total number of iterations to access all the columns of that row. And then when you end, you go back out to the outer for loop and go to the next row. So let's take a look at that. In this example for chessboard, they're both 8 and 8, right? So in our outer for loop, we're going to loop 8 times, 0 through 7. We're going to display row. And then for every single row, we're going to loop on our inner for loop 8 times. So a single iteration here results in 8 iterations here in the inner for loop. And those are the 8 columns for that row. So let's see what happens if we display the value of X and Y accordingly. And let's go run that. Let's see. Alright, let's rebuild the project. And we will run the project. And you can see how that works. Displaying the contents of a two-dimensional array chessboard X and Y, rows 0 through 7, and then column 1, 2, 3, 4, 5, 6, 7, 8. Okay? And those are the values, the numbers stored there, but it's off by 1, so the index is 0, 1, 2, 3, 4, 5, 6, and 7, respectively. See? So just an example of declaring and initializing a two-dimensional array, and then also accessing that two-dimensional array inside of nested for loops, or nested repetition structures, one for the rows, one for the columns. Declaring and initializing a three-dimensional array. Now let's take a look at the next example, and we're just going to uncomment our comment recomment, I guess, the two-dimensional array example. And then we're going to look at a three-dimensional array declaration. And if I scroll down here, three-dimensional array declaration would have 3 subscript values. And you might be wondering, well, where would you use something like that? And a lot of 3D applications, like CAD software, 3D design software, 3ds Max, Maya, games, a lot of them will use sort of an X, Y, Z three-dimensional axis. So that might be a situation where you'd create a matrix with 3 dimensions. And how would that work? Well, if I can get Visual Studio to highlight these 2 curly braces here. There. Between these open and closing braces, terminated with a semicolon, is all 3 dimensions. And then if you look at this first dimension here, let's say that that's x, there's 2. So there's x0, which is all this, and then I'll get Visual Studio to highlight it. There's x1, which is all this. And then inside of each x, there's 2 y's. There's y0 and y1 for x0, and there's y0 and y1 for x1. And then inside of each y, there's 2 z's. Alright, so 2, 2, 2. So 1 and 2 stored in z0, z1, 3 and 4 stored in z0, z1, 5 and 6, 7 and 8, but they're all in different y's and also stored in different x's. So if we initialized our three-dimensional array to contain those values, how would we access it? Well, remember with the two-dimensional array, we used nested for loops. We'll do the same thing with a three-dimensional array, but we have to add in a third for loop to take care of that extra dimension. So in other words, the outer for loop would be the x dimension, the inner for loop would be the y dimension, and the innermost for loop would be the z dimension. Okay, the third dimension. So first dimension, second dimension, third dimension are x, y, z, as I've got them labeled here. Well, look at the way that would work. For every single iteration of the outer loop, this inner for loop here would iterate twice, and then the inner for loop nested inside of it would also in turn iterate twice for every one of these. So this iterates once, this iterates twice, and then every time this iterates twice. And so you can see how we would access all 3 dimensions. And we're just going to display the value stored in x and y and z inside of our innermost for loop. And how would that look? Well, let's build the project. And we'll run the project. Display the results. And we're just showing the value. Display contents of a 3-dimensional array x, y, z. So 1 through 8. As it was set up and stored inside these array elements in our 3-dimensional array. Passing arrays to functions. Now let's take a look at our next example, and let's comment this back. And here in our next example, inside of main, I'm going to uncomment this, we're going to build an array of integers. And I know it's a long name here, but this way I don't have to use excessive amounts of comment tags to explain what I'm doing. The name says what it is and what it does. It's an array of integers, and it's local to the main function up here. Okay, and just to make a point or illustrate a point here, we're going to take this array of integers that's local to the main function, and it's got 5 elements, and it's storing 10, 20, 30, 40, and 50. We're going to pass it to a function. How do you pass an entire array to a function? Well, we're going to do this. We're going to pass an entire integer array. Now remember we said before that the name of an array acts as a pointer to the entire array itself, whether it's on the stack or the heap. In this case it's on the stack. Now normally in C++, unlike Java, by default things pass by value. They only pass by reference when you use a pointer or a reference / alias to the object. But using the name of an array, it always passes by reference because the name of the array acts like a pointer. So if I call this function here, pass an entire integer array, and I simply pass in the array's name, I'll be able to access all of the elements, all of the objects stored in the array via the subscript value just by passing in the array's name. And how would I code the function? Well, if you look, I want to code the function to accept a pointer to the data type of the array. So I pass in the array's name, but when I code the prototype in the definition, I code it to accept a pointer to the right data type. Well, it is an array of integers. So I wouldn't want to code it to accept a pointer to a string, or a pointer to a cat, or a dog, or a monster, or a flying purple people eater. It needs to be an integer. But I can pass in the entire array this way. So let's go look at the code real quick. If I scroll down here, and so if I do this and it comes in as a pointer to an integer, then I can take some array, and using the subscript value on some array, I can go through and I'll be able to display every single element in that array, even though it's local to main. Remember the values that were stored in it? 10, 20, 30, 40, 50? And they were declared up here in main. So I'll be able to display that in the for loop down here. So let's take a look at that. And we'll run it. Display an entire array of integers passed to another function by a pointer. And again, notice, even though that was declared and it's local to main on the stack, I just used the array name and I accepted a pointer to an integer as an argument or parameter, and I'm able to access all of the elements via the subscript value with x on my for loop. And we'll do the same thing with an array of strings. That was an array of integers. Let's look at an array of strings. So I'm going to comment this back, and we'll come over here and uncomment these two lines. And this time I create an array of strings local to the main function. Again, it uses our constant global integer, which has a value of 5, array size. This time it's of data type string, and it's just going to hold the string values 1, 2, 3, 4, and 5, the words. Well, again, like I coded my prototype to take a pointer to an integer, all I have to do is code my function to take a pointer to a string. And then I can take the name of the array of strings local to main function, pass it in as an argument when I call or invoke, pass an entire string array, and I'll be able to use it as a pointer. Pass by reference, be able to use the array name as a pointer and access all the elements inside of it by using x as a subscript value. So in the loop here, I should be able to go through all of those string values and display them. And let's take a look at that. And we'll go here and we'll run the program. And display an entire array of strings passed to another function by a pointer 1, 2, 3, 4, 5. All right.